So let's do another example of equal proportions for chi-squared goodness of fit. So you're providing sodas for your after-school program, and you believe that the flavor of soda doesn't matter to your students. You poll 100 students about the 5 different flavors, and you get the following results. At the 5% level of significance, is your claim true that the students don't care what flavor they get? So another way to say that you don't care about the flavors your students get is that the flavors occur equally. So if I made my hypothesis, my null would be the proportions of all the flavors are the same. And again, remember, the null is the equality sign. It's everything is equal. So that means that I can say that the proportion of cherry equals the proportion of strawberry equals the proportion of orange equals the proportion of lime equals the proportion of grape. The alternative is that the proportions of all the flavors are not the same. You could have other choices that give you equal proportions, but I feel like the ones above are easier to understand. All right, so let's go to Minitab and I'll show you how to put it in. So here, I'm going to make it bigger so you can see it. Oop, it won't. Let's do this. Okay. So here is the flavors. I just put them different. I did cherry. Let me type it in better. Cherry, strawberry, orange, lime, and grape. Okay. So I put in the flavors and I even said the names. So I said the names and then I put in the flavor observed. Why did I do that? Because sometimes when you have Minitab, you'll have a lot of data and you'll get confused about which is which. So I put flavors and flavors observed. So for cherry, it's 32, strawberry 28, orange 16, lime 14, and grape 10. Again, if I go back to my PowerPoint, these were the exact observations given. So in Minitab, I need to make sure they're the same. To solve this, I go to Stats, Tables, chi-squared goodness of fit. And I'm going to, let me show you again, because when you go to this, hopefully your thing is, if it's not empty, you can just clear it out and backspace or delete. So observed counts, I'm going to do flavor observed. Oops, sorry. I hit the wrong thing. So I'm going to go here and do observed counts. And when I click in that box, it only looks for numbers. So for here, it's flavor observed. Category name, I'm going to put it because when it gives me my output, it's very specific about what it gives me. Equal proportions again, because I believe they're occurring the same. And then I hit OK. So look what it did for me. It gave me my categories with my observed values, and then it gave me my proportions. Again, to find the proportions, it is 100 because it's 100% of the data, not the sample size, but 100% divided by the number of categories. So I get 0.2 or 20%. If I only had 4 categories, then it would have been 100 divided by 4 gives me 0.25. So again, remember that your categories and your proportions, to get the proportions, it's 100%, which accounts for all the data, divided by categories. The expected is a little bit different. In this case, I do have a sample size of 100. In the last example, I had a sample size of 60, so my expected were different. So to get my expected, it's my sample size divided by my number of categories. In this case, it's almost the same as my proportions, but just know it could be different. So the expected for each category is 20. Contribution to the chi-squared, it does the expected with the observed formula, and it gives me the contribution. Here, it gives me the sample size of 100. Degrees of freedom is 4. And that, again, is number of categories minus 1. Chi-squared value of 18. And then the p-value of 0.001. So let's go ahead and go back to my PowerPoint and keep going. All right, so you can see the slides where I show you what to do. And the wonderful thing, too, is if I'm looking at the graph, and I can do it here or in Minitab, I'm going to do it in the PowerPoint because it looks a little bit better. Look, cherry, my observed for cherry was really high, and my strawberry was really high, and my grape was kind of low. So I don't know if these happen the same. And that is why when I use my input, I get it. The next couple of slides talk about what happens if you have raw data. If you have raw data, go back to example 1 in this PowerPoint and especially in the video, and I show you how to solve for that. So the conclusion. So from the Minitab results, we see that the chi-squared value is 18 and the p-value is 0.001. So again, I need to put my level of significance in correctly because I had a typo in the last one. Okay, so 0.001 is less than or equal to 0.05. Again, if the decimals are throwing you off, make your decimals equal to each other. Because I had that 5% level of significance, and I'm going to put this here so it might help, 5% equals the same as 0.05. Okay, exact same thing. I just put it down here and I added my 0. So because the p-value is less than the level of significance, I reject the null. Okay, so let me get to my conclusion. Oops. So I rejected my null. Oops, I have 2 of these. Let me get rid of this. So I rejected my null. So since the p was less than that, I rejected the null. That means my null hypothesis is not correct and my alternative is true. So the proportion for all the flavors are not the same. So at a 5% level of significance, the students do care about what flavor they get and the proportions of the flavors are not the same. So when I'm planning to buy soda again, I'll know that, yeah, there were some that were really the favorites of the students. And the numbers that occurred the most, like cherry and strawberry, I probably need to buy more of those and then not buy as many lime and grape because they weren't as popular. That's why you do these kind of tests. You can have a hunch that something's going on, but when you prove it statistically, it gives you A, more confidence, and B, when I give it to another group of people, I can show more than it was just a hunch. I actually did the statistics and I found out that it was true.